Assalamualaikum. Good evening and good afternoon wherever you are. Uh, Let me introduce myself and my friend Rizal Broer and Alam Wahyu Utomo will present it our paper have a title Tackling Feature Selection Problem with Genetic Algorithm in Software Defect Prediction for Optimization. On behalf of the author from IPB University and UIN Jakarta and also from University Pembangunan Nasional Veteran Jakarta, or they call it UPN. Our agenda is have many subjects. First is introduction to SDP, and then background, and then research question, research methodology, result and discussion, and conclusion and future work. Let me start with the introduction of software defect prediction. The structure of the software system will basically more complex and more cost required for the testing process. It has been said by the Otsuki at 2018. And in any area of software engineering, most of results have a defect and failure in that software. And the other researcher say that software deprivation is a way to improve quality by finding and tracking the defective module in software, which help reduce costs during the software testing. And the classification algorithm in machine learning approach is very useful for software defect prediction. It's said by Babu in 2019. Our motivation and background, we are using NASA Promise dataset. Based on that data NASA set, they have a class imbalance. You see the between defect and non-defect. The non-defect is the blue one, and then the red is the defect. You see the relative imbalance between both of them. And the other problem is noise attribute due to irrelevant feature. And this is a method to handling overfitting using balance bagging. You see this figure from original dataset. We try to mapping to balance bagging and then trying to find a better classification. And also, we have used feature selection to improve our software defect prediction. This is an example of all feature, and we select some of that feature and to get a final selection feature. And we try to optimize our feature selection based on genetic algorithm. We try to find objective function and state sorts. In that way, we can find local maximum and global maximum. There are the main two research questions. First is how does the performance of software defect prediction classification with GA feature selection and bagging compare without GA and bagging? And the second, how does the performance of software defect prediction classification with GA plus bagging compare with PSO bagging as a feature selection? Ladies and gentlemen, let me introduce my friend Alam will be continue the rest of this presentation. Alam?
Okay, next, figures show the methodology that will be used in the study. The first step is collecting 6 NASA promised dataset. After that, we apply the data normalization to each dataset. After being normalized, the feature contained in each dataset will be selected using a genetic algorithm to find the optimal feature subset. We implement bagging technique for each machine learning model by applying 10 cross validation to evaluate classification performance based on the selected feature. The performance evaluation that we will use IUC and G-means value. And then we also compare the performance of GA and PSO algorithm as feature selection. In this study, we use 6 dataset taken from NASA Promise public repository. Figures show the activity diagram of the genetic algorithm-based feature selection. After feature selection is complete, the best feature subset is processed to create a classification model to estimate fitness value. Then perform genetic operation include selection, crossover, and mutation until termination condition are met. We use the accuracy of classifier to evaluate the fitness size. The higher the accuracy rate, the greater the fitness. The fitness was defined IUC value. Table 3 show the parameter of selection, crossover, and mutation used were applied using the following configuration. We use 50 value for population size and number of generation. For chromosome size, we use base number of feature is dataset. Crossover probability, we use zero point 0.5. Mutation probability, we use zero point 0.2. And then tournament size selection, we use 3 value. In the proposed method, the chromosome is represented in the form of binary string that is 1 or 0. The value 1 is the selected feature and 0 means it is not selected. The classification model use naive Bayes, Canary Snakeball, SPM, logistic regression, and decision tree. The hyperparameter of each algorithm we use default from scikit-learn library. For performance evaluation, we use IUC and G-means value. Result and discussion. We will now answer our research question. To answer research question 1, table 4 show performance model of all algorithm without GA and bagging. The result is of the 4 dataset used, the logistic regression performance show the highest performance among other algorithm based on the IUC value with the highest value of 85.29% in the TC2 dataset. And then model based on the decision tree appear to be underperforming for all that dataset with the lowest IUC value of 48.97% on the PC2 dataset. In the PC2 dataset, the performance of our machine learning model show a G-means value of 0%, which indicates that the class imbalance impact on the dataset causes the classification algorithm to be unable to severe defect prediction. Table 5 show the performance model of all algorithms with GA and bagging. The result is almost all machine learning models that implement GA and bagging outperform the ordinary and G-means value. Only the PC4 dataset, the result of the performance of the logistic regression with GA show a lowering in IUC value of 1.2%. And then decision tree algorithm is the best by outperforming the three dataset based IUC value with the highest value of 94.61% in the PC4 dataset. Conversely, the naive Bayes and SVM algorithm cannot outperform its dataset test. Figures showed a graph of the comparison of IUC and G-means performance model or algorithm with without GA embedding. To answer Richard's question 2, Table 6 shows the performance model of all algorithms with PSO embedding. The result is all algorithms with PSO get less good result than GA feature selection based IUC value. However, there are several classification algorithms that have improved based on the G-means value, like SPM algorithm, which outperform the three dataset with the highest value of 78.06% on the KC2 dataset. In the case KC1 dataset, there was an increase in the G-means value for the three machine learning model tests. Figures show a graph the comparison of IUC and G-means performance model or algorithm with GA embedding and PSO embedding. Conclusion and future work. In this study, we proposed the combination of Bayesian technique and genetic algorithm to improve the classification performance of machine learning model in software defect prediction. The Bayesian technique was proposed to solve the class imbalance problem and the genetic algorithm for selecting the best subset of feature. The experimental results show that the proposed method achieves higher classification accuracy for almost all proposed machine learning model when compared to original machine learning. The experiment results show that all classification algorithm tests using GA show a better performance increase than PSO but not significantly different. For further research, we recommend that the optimization algorithm is not only applied to feature selection, but can also be applied to optimize parameter in machine learning algorithm like SPM, canary snackboard, and decision tree to improve software defect prediction performance. Thank you.